do some weird stuff. I'm gonna make you guys physically leave here in a second and like walk back in just so we can see it. But you can awkwardly hang out just like we're physically going to practice it. Yeah. Yeah. If you had a bloody nose, that's not an excuse. I'm teasing you. All right. So, you're gonna be so annoyed by this because I'm gonna make you walk right out the door here in just a second again. But, well, everybody agreed with that, but I was more just to her. But whatever, that's fine. All right. Yeah, right. I hate grading them. All right. So, yep, you guys can all leave real quick. Just go walk out and walk back in. We're gonna try it. I should go lock the door on them. They propped it, it looks like. Oh, I'm wondering how. No, they're already come back. Welcome in, everybody. Cool. So, up on the board, there's your groups, and the triple angle formula is what you're deriving. Do it to it.
It's like my science teacher saying Deviant.
Actually, gonna try to do this. So.
Okay, this is how I did it. This is how I did it. I split it into.
If you did it as a what? I'm sorry. It's a great chance to do it. You guys have done most of the legwork. Now, looking around at the boards, what I see is most groups recognized in some fashion or another that there was something that we could change cosine of 2x to. Now, this one's weird because you have three choices, right? Okay, we could change, and I don't remember these off the top of my head, but we could change cosine to cos squared u minus sine squared. We could change it to 2 cos squared minus 1, or we change it to 1 minus 2 sine squared. Now, the only reason that I elected this is known to me, but I want, this is still, what do you mean? I mean, kind of. I just started here, and then everybody started the same, and I should back up. Thank you for asking. 3x, do you agree is just 2x plus x? Okay, so my bad. I did not start from the beginning. And then I recognize, and I just made the comment, this is the cosine of a sum, which as I look at all the groups, every single group also started like this. So on this line, everybody started here. Now, it's here between these two lines where we're going to get all of our variation. I elected to use this double angle for cosine, of which there's three that I can choose. I want to know, in your guys' opinion, and this is a hard question because it's my thoughts, but why did I elect this one instead of writing this? And you don't have to write the pink ones. I'm just looking at the options that I had. I could have done that instead of this. Or I could have made it, what's the other one? Cos squared minus sine squared? Yeah. Cos squared x minus sine squared x. These were the three choices. I've elected this one. I want you guys to take, and I'm going to actually watch the clock this time because I never do this well, 40 seconds. I want you guys to come up with why did I choose the one that's in the middle, the red one. There. Talk it out 40 seconds from right now. I'm going to call in somebody. Yeah, so I agree with that, but I think we can word it differently. Red said, and I'm going to change the words, I think, but tell me if it's the same idea. It's easy to multiply this cosine by a cosine and things don't get ugly. But if I use this, we're going to have a sine squared, cos squared. It's going to get gross. I don't want to use it. This is going to have a sine squared and a cos squared together. I don't want to use it. If I can stick with just cosines, that's going to be the nicest option here, I think. Do we all agree with that? Like just as far as keeping the multiplication straight. They're all three valid and they all work, but it makes sense to use the cosine because we already have cosines everywhere. So if we use this, help me out with the next step. Where we go from here? What's happening? And I'm going to get rid of these for now, or for good. So what's the only algebra weighting? Like we're just kind of taking steps without real clear decisions of where we're going to end up. But is there an obvious next step that we could take? Any algebra waiting to happen? Distribute. I assume it's this one. Now, the other thing, just I haven't addressed it, but I just want to show the only option for sine of 2x is the double angle, and it's just one flavor. Here it is. Okay, so let's distribute this bad boy through then. And what do we get? Two cos cubed, and let me get a part because we're just doing this, right? 2 cos cubed x minus the cosine of x. And then what happens with these ones? Is there any nice rewriting that I can do right now? I'm going to give you a weird comment that's kind of a hint. My commute in the morning is so easy. Oh, I can rearrange. Commutative property just says we can move stuff. I could do 2 times sine times cosine times sine. Could I do 2 times sine times cosine? Which is just 2 sine squared times cosine. Have I lost anybody yet? Love it. I can put the parentheses, but I just added them, right? I'm going to add them in an obnoxious color so they stand out. I'll add the parentheses. That's a great question. Why didn't I care to write them or bother to write them? So, and that's where it's weird, right? Because you don't want to say distribution because there's nothing to distribute. It's just this times this times this times this. What's the difference between what's in parentheses here and there? The subtraction or the addition says we have to distribute. We don't have to on this one. It's the only reason I didn't put it. Cool or no?
Cool.
Okay. All right. Other questions before we keep kicking? Feels okay? Okay. Is there anything else that we can do that's obvious? What? Why did I choose this route again? The cos squared, 2 cos squared minus 1? Because? Yeah, because everything was cosine. What don't I like about this? Well, shucks. If only there was some way to get rid of the sine. Oh, my Pythagorean. Red, you're killing it today. Woohoo! I didn't almost fall. That woohoo was just me trying to not unplug and stop the recording, which, great success. All right. You guys seen Borat? Oh my gosh. I can't recommend it as your teacher, but what's sine squared with cosines in it? 1 minus cosine squared. Okay, well, let's keep working out them forearms here.
What?
Well, if there's a lot of writing. Do your guys' forearms get tired when you write a bunch? My arms get tired. Like, my forearm gets tired. Okay. What are we replacing that with again? 1 minus cos squared. That is a Pythagorean identity, yes. And I would argue it's the Pythagorean identity, the one that we care the most about. All right, we're almost done. What's next? Obvious algebra is what I want. Can I distribute anything more than just the 2? And this is weird, but just to check here, do you guys agree that this is 2 times this and cosine times this? I'm going to save one line of work, and I'm going to pretend like it was written, and I wouldn't take the time with all this writing that I've already complained about. I would not take the time to rewrite it like this. But is that the same thing that's written right here? I have one confirmation. Anybody look at this and not quite sure that we have the exact same thing? If I just have this times this times this, right? If I have 2 times 3 times 4, could I do it as 2 times 4 times 3? Here's the 2 and it's the same idea. You see it now? Okay. All right. So I'm going to distribute, and I'm trying to do this to avoid doing all this writing, which maybe in the end it didn't matter. But let's distribute a 2 cos x into that. So I'll keep this line the same, 2 cos cubed minus cosine x. And help me distribute the 2 cos x minus 2 cosine of x plus 2 cosine cubed. And all of a sudden, we are within stone's throw. Addison, go ahead. When I do a negative 2 cosine x times negative cosine x,
subtract, multiply this with positive. Is that confusing?
It was, but I think I can clear it up. So here's what we had, right? Do you agree that if I'd just done this first, I'd have negative 2 plus 2 cos x, 2 cos squared x?
I don't know. What to bring the negative and what to not.
If you're multiplying, does it matter if you're multiplying by a positive or negative?
Yes.
Bring it if you're multiplying. 100% of the time. Okay. And then this is where the plus comes from, just so you can see it here. Okay. All right. What's the last line? We're almost done. We have literally one line left. What is apparently the nice triple angle? 4 cos cubed. We're just combining our like terms. Anything else? 3 cosine of x. And all of a sudden, we now have a new formula in front of us that, I'm going to be honest, and you guys are going to hate this, is the value in mathematics always the immediate application of the math, or is the value in realizing that we can do really hard problems that aren't really that hard when we go through them? What's more valuable? That was a lot of words to think about. I tell you, I think they're both really valuable, just to be honest. But I do think that there's more value in being able to do this than you're going to get out of having this, just so you know. This is a good exercise in just to see, like, hey, we could do this. We could do it for a quadruple or a quintuple or a sextuple. We could do it for any of them. We're going to use a similar process. As long as we're practicing manipulating stuff and making sure we understand, like, hey, the math is nice if you treat it like it's nice. Maybe not super nice. I don't think you're ever going to use the triple angle formula. I'm sorry. But it's a good derivation nonetheless. Okay. Are you guys tired of doing this stuff? Do you want time for homework or do you want to finish up the chapter? Okay, well, we're going to do both then since I heard 2 people respond and they were exact opposites. We're going 15 minutes for an assignment and then we're going to jump in to the conclusion of 5.5. Cool. So, for the next 15 minutes, I want you guys working, and I'm going to likely add problems to this tonight. We'll see how far we get after this 15 minutes. Homework 5.5.1 we'll find on page 389. And I want you guys to do problems 7, you know what? I lied. 11 through 21 odd. (11 through 21 odd), and notice there's a comma because we're going to have more stuff after the second half. 15 minutes, right meow. Any music preference that stands out above the rest? Okay, cool. Well, this will ring in 10 minutes, and then we'll give it 5 more. Sweet. I'm not going to add any problems tonight, but I'm going to make it so that we have a setup ready for our bell ringers tomorrow. Okay. Anybody have a funny joke that you want to tell before we dive back in? The second you guys graduate, I have like a million jokes to tell you, but I can't tell them right now, especially on a video. All right. I made a mistake one time in saying a kind of on the fence joke that somebody gave me. Like, I asked a question, like, it's a silly punchline. I'm not going to tell you the joke again. When you graduate, I will. But I asked the question, and the person gave me so much more inappropriate of a response than the actual punchline would have been that I've just decided I'm not going to tell jokes like that anymore. So here we go. Last little part of it. I'm going to be honest. I'm skipping some stuff that is not in your trig cheat sheet. They exist on your trig cheat sheet. Do you have the power reducing formulas? Okay, so they exist. If you want them, I'll give them to you. Your book has them. Your book is a super valuable resource. I definitely do not cover every single thing that the book does, which means if you get a problem, I've definitely given you the tools needed, but you might have to turn back a page or two. Just as a reminder, there's a digital textbook, thanks to a little bit of pirating activity, that we have available to us. Cool. All right. The last little thing that we're going to talk about in here, we have just finished up the double angles just now, and we saw a triple angle, and apparently there's a quadruple angle that we can use also. They exist for every single one. This is still 5.5. It's the last one. And these are our, that should be a capital A. We're going to look, and I'm not sure if these are on your cheat sheet either, the half angle formulas. Okay. These ones, I guarantee the double angles are also valuable, but it's harder for me to come up with an example. These ones are super easy. Half angle formulas. I would add these in your notes, add them on your trig cheat sheet. Here's my easy question for you. What's the cosine of 30 degrees? Cosine of 30 degrees. Root 3 over 2. Okay. What's the cosine of 15 degrees? Half of that. But you don't know it. Would you think it's half of it? Well, what's the cosine of 30 degrees? Sorry, 60. 1/2, and it's half of a half, root 3 over 2. So it's not just half of it. Although the angle is half the angle, the cosine is not just half of it. And it's like we can see that concrete example of it. But if we know 30, there must be a way to get 15. Or if we know 45, there must be a way to get 22 and a half. Like a bunch of these weird angles that don't show up. The cool thing is the formula is not terrible. The bad thing is every single one of these answers looks kind of the same. They're ugly numbers. You're going to give me exact answers, never approximations for these. What kind of answers are we going to use? Deal. All right, so check it out. I'm gonna give us all three of them. First one, and we'll switch colors. Let's do the sine first, and I should probably switch doing cosine first since it's x, but it's so ingrained in me. What angle are we using? U or theta? Theta. Everybody prefers theta. Cool. So here's U. Doesn't matter. You can write theta if you want, just so you know. But I want you to not just get used to only theta. Okay. If we want to take the sine of u over 2, we need to know what u is. So in that example, if I wanted the sine of 15 degrees, what is u? 30, because 30 over 2 gets me to my 15. Okay, so for this, we're going to use the following formulas. We have the sine of u over 2 is plus or minus, and we'll have to talk about that. And it's a square root of a fraction. So leave enough space to put a vinculum in here. Nobody batted an eye. What did I tell you to leave space for? What's a vinculum? Why wouldn't you ask if I said to leave space for it? That's right, it's a fraction bar. Okay, so 1 minus the cosine of u divided by 2. That's it. Okay, the cosine of a half angle. So the cosine of u over 2. Turns out very similar. Plus or minus the square root, little tiny change here. 1 plus the cosine of u all over 2. Okay. My zoom here. So let's see. I've already done green. What color is tangent in your head? Interesting that you guys were all committed.
You just said that yesterday, though.
Did I? I don't remember what I say ever.
Tangerine, yeah.
Oh, interesting. Okay. The one overused math joke that I want you guys to all make sure you get this summer and take a photo. I'll make this assignment for the fall if you're in my class. When you go somewhere sunny, you should put on sunscreen that has sine theta over cos theta on your body. Like write sine theta over cos theta on your body in sunscreen and let it not tan. Because what does it mean? If you look at, like, if I pulled down and said sine over cosine, you're going to say, man, that's a sweet tan. Okay, excellent. I'm going to buy a trap set for this route, so actually I just need a hi-hat and a snare, but prepare for that. Okay, tangent, half angle, last one. And there's 2 flavors of this. No plus or minus. It is either 1 minus cosine of u divided by the sine of u, or, and we'll do the same thing here, we could have it instead as the sine of u. Man, my u's and n's look identical. Can't stop it. All divided by 1 plus the cosine of u. All right. There's one little thing that we need to make sure that we can address. If I want to use this, notice sine and cosine, they both have plus or minus on them. How would we decide which one it is? So I heard somebody say quadrant right off the bat. 100%. It's a quadrant right off the bat. And I want to just notice something. We don't have to jot this down. Pick any angle in quadrant 2. And give me degrees. It's going to be easier to think about in degrees. Shout an angle in quadrant 2. 100. Cut it in half. And it's in which quadrant? Quadrant. Okay, what's the biggest angle we can get in quadrant 2? Like, I wouldn't say it's in quadrant 2. Can we say 179? Divided by 2, we'll use 178. Divided by 2 is 89. And that wound up in quadrant 1. So if I was taking the sine of, I don't know, whatever u over 2 winds up, we just pay attention to where u over 2 is. So if it's in quadrant 2 and you cut it in half, it ends up in quadrant 1 every time, right? What about quadrant 3s? 181 and 182, because it's easier, divided by 2 is what? 92. So if you take a quadrant 3 angle, seemingly, it takes you back to quadrant 4 if you cut it in half. Sorry, quadrant 2. I just got really goofed up. Did you guys follow that? Okay, we're going to make a note here. That's my bad, because that's too many words. All right, caveman talk. Let's do it. It's not going to be caveman talk. The sine, and this is misleading, sine with a G. The sine of cosine of u over 2, or the sine of u over 2, which we're deciding between these plus or minus, is dependent on the quadrant, I'm going to say which quadrant, u over 2 is in. That's it. Now, what I was doing a second ago is I was just picking angles in quadrants 1, 2, and 3 and saying if we cut it in half, where do we wind up? So another angle in quadrant 2, for example, is 190 degrees. That's, sorry, quadrant 3. 190 is in quadrant 3. Do we all agree? And half of that is 95. And 95 would be in which quadrant? 2. So what we see is like we're just kicking down a quadrant. Does the same thing happen in quadrant 4? If you go 350, what's half of that? 175, and that kicks us to which quadrant? 2. So you have to really think that out while you're going through it. Which quadrant does half of this live in? Okay, that's how we decide the signs. Now, we're at a weird situation here, and I think you guys are going to like this because I don't think 5 minutes is sufficient for us to do a half angle problem right now. But here's the cool part. With 5 minutes left, it gives you 2 opportunities. You can write these formulas in your trick cheat sheet, and you can continue working on the assignment for 5 more minutes. The bell ringer tomorrow will be half angles. These formulas will be up. I'll have them ready for you when you get in here at 4th hour tomorrow. The double, ooh, no, you have the doubles. We're gonna, sum and difference? Sum and difference then. Yep, cool.